All right, I wanted you to do one more example of finding this area of a sector that is taking away this triangle that we see here. So let's take a look at this circle, and I have this circle with radius 11. And if we look at this, we are able to find the area of this shaded region in purple there. Now, what I want you to do is take some time and determine if you can find the area of this pink shaded region right here. Okay, tell me if you can find the area of this pink shaded region right here. Pause the video so you can see if you can figure it out yourself. All right, taking a look at this. As a reminder, what our kind of end goal here is we are going to first find the area of a sector, because if our area of that little shaded region is the area of the sector minus the area of the triangle. So if I can find the area of the sector, then I can just find the area of the triangle and subtract the two. So the first step is to find that area of the sector. And again, as a reminder, the equation to find the area of a sector is the area is equal to n divided by 360 times by pi r squared, okay? And again, the n divided by 360 really just tells me what portion of the circle am I trying to find the area of, and then pi r squared is the equation for the area. And so looking at this, n is 98 divided by 360 times by pi times by 11 squared. Let me do this, put the parentheses around 11, and here we go. Okay, again, simplifying this solution, 98 divided by 360, 98 divided by 360 is 0.272. Okay, so that's, I want 27.2% of the circle, and I want to find the area of that. So that would be 121 times by pi. 11 squared is 121, and then times that by pi. Okay. Now we're almost done. To find the area of the sector, the area of the sector is 0.272 times by 121. That is 32.94, and then multiply this by pi. So 0.272 times by 121 is 32.94, and I want to multiply this by pi. So 32.94 times by pi, which is 103, so the area of that sector is 103.48. Okay, 103.48 units squared. Okay. So that is the area of the sector. Now what we're trying to do is, well, now we must find the area of the triangle. And when we find the area of the triangle, the steps upon which we find the area of the triangle are the same for each. And actually, I'm going to move this over here and do the area of the triangle over back on this side. Okay, so step 2 is to find the area of the triangle. Step 2, find the area of the triangle. And when we do this, what I'm going to do is I'm going to redraw this triangle right here. So let's redraw this triangle. I'm going to need to do this with line segments because they only allow me to do acute and right triangles here. So I'm just going to redraw this at this point right here. So this is 95 up, 98, sorry. Okay, and I know that this is 11 right here, This side length right here is 11, but I also know that this side length right here, and I'm going to highlight this in green, this side length right here is also 11 because this side length is 11 and it's the radius of the circle, while this side length here is also the radius of the circle, and no radiuses are different, so this must also be 11. Which makes this triangle an isosceles triangle. Whenever you do problems like this, you should always get an isosceles triangle. And when I divide this by 2, this allows that these base angles to be both 41 degrees. This is 180 minus 98. That is 100 and, I'm sorry, that's 82. So 180 minus 98 is 82. 82 divided by 2 is 41. So these two angles must add up to be 82 because this is 98. And because it's an isosceles triangle, these base angles are congruent, making them both 41 degrees. And it's at this point now, whenever we would have gotten to this part of the question, is we would have drawn this altitude. Now, if I would have drawn this triangle perfectly, what occurs here is because I'm going to do this in blue, because this is a right angle here, because that's what an altitude does, and it's also another name for the height, because this height or this altitude makes a right angle to the opposite side, what I can say is, well, if this is 41 degrees and this is a right angle, then this right here must be 49 degrees. Because 41 plus 49 plus 90 gives me 180. But if this is 49 degrees and the entire thing is 98, then this also must be 49 degrees. It's an angle bisector. This altitude for all of your questions are going to be forming an angle bisector. Let me actually re-erase that because that was terrible. 49 right there. And now at this point, because both of these angles are congruent, the opposite sides are also congruent. And this is when I would have said made them both x. Okay, although again, because I drew my picture a little poorly, it doesn't look like it, but it is. They're both x degrees, or sorry, x units long. And so to find the area of this triangle, what I need to do is I need to find the height and I need to find the base. And so what I can use is something that we were talking about last chapter, which is the, or earlier this chapter, which is the trig functions. And so what I can say is if I look at the base angle 41, well, the height of that triangle is the opposite side of that base angle 41, opposite. And I also know the hypotenuse. So I know the opposite side is what I'm trying to find, and the hypotenuse is 11. So opposite over hypotenuse says that the sine of 41 degrees is equal to the height divided by 11. Opposite side, which is the height, divided by the hypotenuse, which is 11. Whoops, didn't mean to do that. And let me just hit undo twice. And now at this point, what I can say is, well, let's just multiply by 11 to both sides. So let me actually draw that in. Let's just multiply both sides by 11. And what we're going to end up getting here, oops, I did it again, is the equation to find the height is 11 sine of 41, which is going to be the height. And 11 times the sine of 41 makes the height 7.2. So the height is 7.2. So the height of the triangle is 7.2. Now I just need to find the base because the equation for the area of a triangle is 1/2 base times height. Well, I have the 1/2. I now found the height, so I just need to find the base. And to do that is very similarly. The base here is, well, half the base x is the adjacent side. All right, so this x here, this part of the base is the adjacent side to the base angle 41. And so because we are looking for the adjacent side and I still have the hypotenuse, at this time what I'm going to do is the last step is find the cosine. So the cosine of 41 is equal to the adjacent side, which is x, over the hypotenuse, which is again still 11. And to find x is going to be the same way we found h. And in fact, what we're going to do is multiply 11 to both sides. And we're going to find out that 11 cosine of 41 is equal to x. And when I put this into my calculator, 11 times 41, the cosine of 41, I get x to be equal to 8.301. Okay, and so at this point, if x is 8.301, then 2 times x times that by 2, the entire base is 16.6. So the entire base is 16.6. This whole thing is 16.6. Sorry, that's kind of crammed in there. But if x is 8.3, this is 8.3, then the entire thing is 16.6. And so at this point, I can find the area of the triangle by doing 1/2 times the base, which we just found that the entire base was 16.6, times the height, which is 7.2. And what we're going to find out this being is 7.2 times 1/2 times the base. I'm going to get that the area of the triangle here, the area of triangle is going to be 59.76. 59.76. And when I do, at this point now, I found the area of the sector, I have the area of the triangle, and now my end goal here was to take the area of the sector and subtract the area of the triangle. And so at this point here, I'm actually going to write this down. I just stop the drawing here. I'm going to actually write this down here. The area of the shaded region is equal to the area of the sector, which we found in 1 to be 103.48, minus the area of this triangle, which is 59.76. And we get the area, I'm actually going to move this down, the area to be equal to 43.72 units squared. That is the area of that shaded region. Let me make sure I do my units squared. Units squared. And I forgot to put that here. This is units squared for the area of the triangle as well. Units squared. This is my final answer. Okay, I hope this helps. But again, the process to solving all of these questions are the same. Find the area of the sector, find the area of the triangle, and subtract the two. Okay, let me know if you have any questions or if you want me to go over any more. I can do that as soon as I can. But other than that, have a good rest of your day. Good luck on your quiz that we're going to have next time. And I'll see you then. Thanks.